Hi everyone. Today we're going to study multiplication of radicals. First, let us have the product property of radicals. Suppose there are two radicals here, the nth root of A and the nth root of B. Take note that the index are the same. And n, and that is the index, is greater or equal to 2. And the index is also an integer. Then, if we multiply the nth root of A by the nth root of B, the answer will be the radical with the same n index with the product of A and the B. So you see here, the answer is the nth root of AB. This equation here is what we call the product property of radicals. Let us apply that principle for some examples. Let's have this example 1. Find the product of the cube root of 6 and the cube root of 2. The formula is here. As per the requirement, the index must be same. As you can see in this problem, the index are same and equal to 3. So what we'll do is simply take the radicands, the 6 and the 2, multiply them together, and the final answer is cube root of 12. Let's have example 2. Let us find the product of the first term 10 square root of 6 p cubed times 4 the square root of 3p. I put the formula here on this side, and there is a rule. We will multiply the numerical coefficients and multiply the radicals respectively. So in here I multiply the 10 and the 4, and that is 40. And for the radicals, I must check first if the index are same. So both are square roots, so we have the same index of 2. So we are to multiply now the radicands. So the 6 is multiplied to the 3 becomes 18. The p cubed times the p equals p raised to 4. So this is our answer. But I observe our radical here can still be simplified. So what we'll do, we're going to factor out 18 into two numbers such that one must be a perfect square. So that is 9 times 2. The number 9 is the perfect square number. For the p raised to 4, we're going to show that this is p squared and again squared. After that, we're going to distribute the radical to each of the terms inside the radical symbol. So we have now, first the 40 I copied here, times the square root of 9, times the square root of 2, times the square root of that p squared and again squared. The next is, we will show that 9 to be a 3 square value. And then, we are now to simplify further. I copy first the 40. On this term, I cancel the radical along with that power 2. So only the base 3 will come down. For the square root of 2, we simply copy here. For this term, we cancel the radical along with that power 2. So only the base p squared will come down here. So on this point, we're going to combine all terms that are not inside the radical symbol. So this 40 will multiply to 3, also multiply to the p squared. So it becomes 120 p squared, and also the square root of 2 will be copied here. So this is our final answer. Let's have example 3. There are two binomials with radicals that we will multiply. The first group is 3 square root of 2 minus the square root of 5. The second binomial, the square root of 2 plus 4 square root of 5. As per the rule, we will multiply each term of the multiplicand to each term of the multiplier. So the first group is the multiplicand, the second group is the multiplier. So if I'm going to take the first term, I'm going to multiply this to the two terms of the other group. After that, I will take this second term of the first group, then multiply to all the terms of the second group. So let's start with the first term. The 3 square root of 2 is multiplied to this square root of 2. We will get this 3 square root of 4. Next, the 3 square root of 2 times 4 square root of 5. We will get this 12 square root of 10. Now for the second term, I will multiply this negative square root of 5 to square root of 2. I will get this negative square root of 10. The negative square root of 5 times 4 square root of 5 will have this negative 4 square root of 25. Then let us simplify the first term. The square root of 4 will be 2. Later on, we will multiply to the 3. So the second term we copy also here. The third term also. For the fourth term, we can simplify this square root of 25 to be 5. Then later on, we will multiply to the number 4. On the next line, now is the product. The 3 times 2 is now showing as 6. Then for these two terms, they are like terms. They have the same radicals, same index, and also same radicand. So we can combine them. We will only combine the numerical coefficient. So this is positive 12 and this is negative 1. So it becomes positive 11. And then copy the same radical, square root of 10. Then minus the product of 4 times 5 is 20. And in here we can combine the 6 and the negative 20 to be negative 14. Then we will copy this radical down here, plus 11 square root of 10. So this is our final answer. Let's have example 4. This is now the square of the quantity 4 minus 2 square root of 5. We can expand this binomial here to be 4 minus 2 square root of 5 times 4 minus 2 square root of 5. And then we will do the long multiplication. Start with 4 times 4 is 16, and then 4 times negative 2 square root of 5. We will get this 8 square root of 5. Next, the negative 2 square root of 5 times 4. We will get this negative 8 square root of 5. And then negative 2 square root of 5 times negative 2 square root of 5. We will get this 4 square root of 25. And then we will simplify this square root of 25 to be 5. In the second term and the third term, we can see that they are the same radical. It means we have radicals of the same index and the same radicand. In that case, we can combine these two radicals in the middle. So in the third line, we have this 16 here, and then combining these two terms, we have this negative 16 square root of 5, and then plus the product of 4 and 5 is 20. So we can now add the 16 and the 20, it becomes 36. Then we simply copy this negative 16 square root of 5. So this is our final answer. There is another solution using a special product formula. So what I will do, I'm going to solve this same problem using the special product. First, I'm going to clear the board and then put the final answer on this side, the 36 minus 16 square root of 5. and I'm going to use the special product, the square of difference of two terms. In the answer, we will have three terms, so it means the x minus y quantity square is equal to these three terms, x squared minus 2xy plus y squared. So for the answer here, I am putting here three blanks to represent the three terms for the final answer. The first blank here is for this 4, I copied here and I put the power 2. Then for the second blank, I put these two terms here, the 4, and also this negative 2 square root of 5. So you see here the 2 square root of 5, the negative sign is already here. And then this number 2 here is a constant that we should always place. And the third blank is for this term negative 2 square root of 5, and we will put the power 2. So we were able to place all the necessary values. So we will now to simplify. The 4 squared becomes 16, and then minus. Then the product of these three terms, 2 times 4 times 2 square root of 5, we will get the 16 square root of 5. And then plus, we're going to square this term. Because of the square, the negative sign will go away. The 2 here becomes 4, and the square root of 5 is square. The radical sign is cancelled with the power 2, so we'll have the 5 only that will come here. Then we will simplify, the 16 comes down, then minus 16 square root of 5, multiplying 4 and 5 becomes 20. Then we will combine the 16 and 20, so this answer here is the same with our answer a while ago when we solved this using the long method of multiplication. Thank you for watching. See you again next time.